Everyone, and welcome to chapter one. Welcome to your first day of class. Today in this chapter one is Introduction to Statistics. In this section, you're going to see a lot of definitions and a little bit of everything. So hopefully um, we'll start. So in this section, we'll start with statistical and critical thinking. Again, a lot of definitions, a lot about critical thinking, a little bit of background of what statistic is, and then we'll go from there. What is the key concept of this section? The process involved in conducting a statistical study where consists of preparing, analyzing, and concluding statistical studies. Statistical thinking involves critical thinking and the ability to make sense of results. So it's not just here's a number, here it is. It actually has a meaning. We have to interpret results in statistics. We have to critical think, and we have to think statistically, since it demands more than just the ability to execute complicated calculations. I'm not going to say, oh, find the solution of x plus 2 equals 5. Let's solve for x. No, it actually has meaning. We're going to be working with preparing, analyzing, and concluding analysis. The first thing you want to know is the definition of a data. What is a data? Data is actually a collection of observations, such as measurements, gender, or survey responses. Data can consist of literally anything. You can collect data from different types of study and observation. So the key word for data is a collection of observations, different types of observations. Statistic. Now, statistic is the science of planning. So one thing is data. Now, what do we do with the data? We collect statistics, which is the science of planning studies and experiments, obtaining data, organizing, summarizing, presenting, analyzing, and interpreting those data, then drawing conclusions based on them. So basically, we take the data, we are going to organize the data, summarize the data, present the data, analyze and interpret, and then base a conclusion on all that. So two different things. We have data, which is a collection of observations, and we have statistics. What do we do with them? Now we have another thing called population. Now, population is different than statistics. A population is a complete collection of all, not just some, but of all measurements or data that are being considered. Typically, a population is a complete collection of data that we would like to make inferences about. And the key word for population is all. It's a complete collection of data. So it's not just a piece. It's not just some data, but it's actually all data, all measurements. So the key word for population is all measurements. Is all, not just some. So let's talk about census versus a sample. Well, remember a census, hopefully you guys all know what a census is when you take the collection of data from every member of a population. So from every member, when you're trying to find the census, basically you're trying to determine how many people do we have. It's every member in a population. Now a sample is a sub-collection of members selected from a population. So a sample is a sub-collection where a census is every. So every or a sub-collection. Those are the two different things between a census and a sample. Now let's look at some examples. So we've looked at some definitions. So in the journal article, Residential Carbon Monoxide Detector Failure Rates in the United States, it was stated that there are 38 million carbon monoxide detectors installed in the United States. When 30 of them were randomly selected and tested, it was found that 12 of them provided an alarm hazardous carbon monoxide condition. Now, we're trying to determine what is the population and what is the sample. Remember, the population is all the members, all versus a sample is a sub-collection. So the sub-collection of the example was the 30 carbon monoxide detectors, right? We only got 30 of them, while there's actually 38 million. So we're looking at what's the difference between what's the population and what is the sample of the following example. Now, the objective is to use sample data as basis for drawing a conclusion about a population of all carbon monoxide detectors, and methods of statistics are helpful in drawing such conclusions. So when we are working with methods of statistics, most of the time, we're only going to grab a sample. So we will grab a sample instead of a population. And then we will make conclusions of that format. So then what we've had is we're not going to look at all 38 million of these, but we're only going to look at a sub-collection, and then we're going to do our conclusions based on that. And it's pretty much a lot of accuracy, believe it or not. So what is the procedure of statistical and critical thinking? What are the steps? Well, we have step one, which is to prepare. We have to prepare the data. So what data are we going to represent? What does the data represent? What is the study of the data? What is the source of the data? What type of sampling method are we going to look at? So we're going to look at what is an unbiased way or what is a biased way and what's the difference. We're going to look at that. We have step two, which is analyzing the data. So preparing the data, then analyzing the data. How do we analyze the data? We analyze it by graphing the data, exploring the data, and apply statistical methods. That's step two. And the last part, one of the critical things, is step three, which is to perform your conclusions. What is the significance? What is the statistical significance? We'll talk about that. So pretty much in this semester, we're going to look at all of these pieces. We're going to prepare the data, we're going to analyze the data, and then we're going to conclude the data. What is this data about? So let's look at the first part. Here we have a sample. Let's look at the preparing portion. Pleasure boats and manatees fatalities from a boat encounter. So here we have a relationship between pleasure boats, 10,000. So this means 99, 10,000, 97, 10,000, and then manatee fatalities. So let's look at this context, because that's the first part, to prepare the data. What context? So we're following pretty much this data. We're going to prepare. So we need to know, what does the data represent? What is the goal of this thing? So what does this table include? Includes the number of registered pleasure boats in Florida in tens of thousands, and the number of manatee fatalities from encounter with these boats in Florida for several recent years. This format of the table consists of a relationship between the number of boats and the manatee deaths of boats. So if we see that there exists a correlation, 99 and 92, we start to see, okay, well, the numbers of pleasure boats with manatee fatalities exist a relationship. Now, what is the source of the data? Where is the source coming from? It's coming from the Florida Department of Highway Safety or Motor Vehicles, from the Marine Research Institute. They should know, where is this coming from? Where is the source coming from? And we need to know that the sources are reputable, so they make sense. What type of sampling method? Well, the data that we're obtaining is from official government, and the sampling method appeared to be sound. What does it mean to appear to be sound? Some validity, so it has some validity. So it's high responsive. It means it has meaning. It has sound. It's creating something. It's being noticed by the police department. Now, see how as we increase, the fatalities also increase. As we decrease, the deaths also decrease. There's just a correlation. Okay, so it does have sound. And that is to prepare. Just looking at the first part, what is the context of the data, the source of the data, and the sampling method. Those are the three things that we just saw with this example. We looked at the context of the table, we looked at the format, and then we looked at the source and the sampling method. Okay. So if there exists a relationship, that means that there is some sound. Now there's something called a voluntary response sample. A voluntary response sample or a self-selected sample is something different. That's when somebody decides to be included in. So for example, when you are walking around campus and people are trying to get a survey from you, that is a voluntary sample. So a voluntary sample is, so as an example, would be like a survey. You decide to participate. Okay, if this is like a survey where you decide to participate, you decide or not. Okay, self-selected sample. The following types are commonly examples of a voluntary response sample by vary of their nature or seriously flawed from conclusions about a population on the basis of the sample. But the difference is when there's a voluntary sample, there is a strong possibility of being biased. So people that feel very strong about something will have a bias towards one or the other. So for example, an internet poll is who decides to participate, yes or no. A mail-in poll, and let's say, for example, people who are voting. There's a lot of people that are biased and do want to vote, and they do all their surveys. They participate in the votes, and then they return the mailing votes. There's some people that don't care, they don't want to participate, but then one dominates the other, right? There's a stronger bias if you feel strong about something. There's also telephone call-in polls that say that you're at like a member service and like, oh, if you like the service, stay within your line within 2 or 3 minutes. And then you're like, oh, I really like this person, so I'm just gonna like give her like a high five or something. I'll give her a 10 of my vote. So again, this is more of a voluntary that you can register your opinion. That is a voluntary sample. What would be another one? So Nightline asked viewers to call about their opinion about whether the UN headquarters should remain in the United States. Viewers then decided themselves whether to call yes or no. And 67% of 186,000 said that the UN should be moved out of the United States. This is for the call-in opinion. Now, in a separate independent survey, asked 500 respondents who were randomly selected, and only 38 of them wanted to move out the United States. So then we could see the difference between when it's a call, it's more of a, oh, I feel strongly about something, I'm going to call. So 67% of the 186,000 will want to remove. Now in a survey of 500, right, only 38 of them wanted to move out of the state. So then what can we look about the two different surveys? Well, the two polls produced a dramatic difference in the results. One was an independent survey. The other one was a voluntary. So the volunteer response, which much smaller, right? When you have the Nightline poll versus the independent poll, then the randomly selected respondents is more likely to provide better results because of the sampling method. So the independent sample of randomly selecting respondents creates a better, has a superior sampling versus sampling method versus the voluntary. Okay, so that's what we can kind of improve. That the independent sample of a randomly selected respondent has a superior response or a superior method of sampling versus a voluntary sample. Okay. Now, that is all the pieces. Now, when we're analyzing the data, so all that was for the first part, kind of the context, what type of sampling method are we going to do? What is biased? What's unbiased? So again, bias would be like a voluntary sample. Unbiased would be like an individual sample or a sample that is randomly selected. Now, when you're analyzing, now here you're in step 2. After completing your preparation, by looking at the context, the source, and the sampling method, we begin to analyze the data. How do we analyze the data? Well, we graph and explore. We can graph. We can do graphs where there's something called bar graph, histogram, Denometer, and more. So these are just some that we're going to learn this semester. An analysis should begin with an appropriate graph and explorations of the data. We're going to be applying good statistical methods that does not require strong computational skills. A good statistical analysis does require some common sense and paying careful attention to sound. So again, sound statistical method. So the importance of it has importance. There's a correlation, a relationship, things that have sound in statistics. Is it having an impact? Yes or no? And step 3 is to conclude a course, is to conclude the final step in our statistical process involves conclusions, and we should develop an ability to distinguish between something called a statistical significance and a practical. What are the difference? Well, we have something called statistical significance. The statistical significance is achieved in a study in a likelihood of an event by occurring 5% or less by chance at 5% or less, meaning 95% or more. That's the key. So getting 98 in 100 for is statistical significance. Well, because it doesn't occur by chance, if we look at 98 out of 100, that's 98%, which is, well, 98% is more, greater than 95%. That tells me I am statistical. Whereas the second one, getting 52 out of 100, or 52 out of 100 is 52%, which is less than 95%. This is not statistical evidence. Because it does not have 5% or less. So 95% or less would be 95, 96, 97, 98, 99, up to 100, which is statistical significance. Now, practical significance means it's possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use or be practical. So the findings or the treatment does not make it enough of a difference to justify or to be practical. So these studies are more of, is it worth it or is it not worth it? They don't have statistical significance. We're just looking whether something is practical or not practical. Is this study is worth it or not worth it? That is the difference. Now we do have another example before we jump to section 1.2. Let's look at example 4. Statistical significance versus the practical significance. So ProCare Industries once applied a product named Gender Choice that supposedly increased the chance of a couple having a baby with the gender that they desired. In the absence of any evidence of this effectiveness, the product was banned. The product was banned by the FDA as a gross deception of the consumer. Now, let's look at the study. Suppose that the product was tested with how many? 10,000 couples who wanted to have baby girls. The result consisted of 52 or 5,200 baby girls in the 10,000 batch. This result is statistically significant because the likelihood of occurring due to chance is only 0.003, which doesn't sound like a feasible explanation. So when we saw this, this is 5,200 over by 10,000 births. So these canceled 52 out of 100, right? And when I noticed 52%, this doesn't fall within a high statistical significance, right? It's not statistical significance. It doesn't have much, so that means it's not feasible for an explanation, right? So that 52% is statistical significant, but it lacks practical significance because 52 is only slightly above 50%. So couples do not want to spend time and money to increase the likelihood from a 50% to a 52. Okay. So in reality, the likelihood of being a baby girl is about 48.8%, not 50%. So for example, when you're looking at the study, you first look at, okay, well the 95%, which would make it statistically significant. And looking at the 52% versus the practical. So the practical is more of 52% versus the 50%. Where is this 50% coming from? Well, boy is 50%, a girl is another 50%. So we have to look at more about the study in general rather than just the selection. So when we're looking at the statistical significance versus the practical, it's only 2%, which lacks spending too much money on this gender, this ProCare gender. So then that would mean that the FDA will not approve just by 2% because there's still a risk of not having the sex that you desire. Okay. When you analyze data, there exists potential pitfalls that happens all the time statistically. We can have misleading conclusions. So even though you did all the tests, you can have a conclusion to be false. But when performing a conclusion based on statistical analysis, we should make a statement that are clear, even though we don't have no understanding of statistics and its terminology. Sometimes the sample reported and it's reported and not measured. So for example, I can say, oh, I weigh 130 pounds, when in reality, I'm not being measured on a scale and I actually weigh 140. So sometimes when you're collecting data from people, it's always better to take measurements instead of asking. So for example, it would be an example. So I report my weight. Let's say I report my weight of 30 versus measuring me in a scale and weigh 140. Right? There's a difference. So one thing is to report and one thing is to measure. That's another way to lead into pitfalls. Loaded questions of a survey are not worded carefully. The results of a study can also be misleading. So it's also the way that a sentence is written. If I put something first then another, that kind of leads into analyzing things that are misleading. Another potential pitfall that could exist when you analyze data is the order of the questions are unintentionally loaded, and some items are being considered. Some will have no response. Some people decide not to respond, or it's unavailable, so then you don't have the accuracy. Some percentages, some studies cite misleading percentages. So sometimes note that 100% of the quantity is all, but there's some references that actually exceed 100%. And that's not justified. So for example, in the news or in the newspaper, you can see things like, oh, 20% of all dogs can eat this and that. But maybe they're looking at cats and dogs, so it's more than 100%, right? And that terminates section 1.1. So hopefully, as we're going along, we're kind of determining and analyzing the things that can occur in statistics. So we are going to look at the context of the statistics. We're going to look at the data, what type of sampling. We're going to be analyzing through graphs, and then, of course, doing our conclusions, which can lead to potential pitfalls that we just think. So hopefully, again, this is just a brief introduction of what statistics is. We are going to move on to section 1.2. So hopefully you guys are still with me.